Welcome. In this video I'm going to be reviewing a PC board manufacturing service. This particular service is called JLCPCB. If you've watched my videos, you may have seen me review some services before. So I'd like to state up front that I did receive some incentives in exchange for doing a review, including but not limited to some free PC boards. I can't turn down free PC boards because I like to make lots of boards, so getting a few for free is always good. But that won't bias the result of my review at all. I'm going to give a good, honest review and show you how I generated the boards, how I submitted them, what came back, and then hopefully, if all works out, we'll build something with them. So I'm going to send two designs in. I've done a few of these PC board reviews in the past, and my methodology that I think I'm going to go for is to with this and future reviews is to try to submit one board using the cheapest manufacturing possible with the service, and then one board that uses some of the more expensive manufacturing. So the first board we're going to get down to 100 millimeters per side or less. That'll qualify for their cheap pricing. We'll make it in hot air solder leveling. We're just going to be as much a no-frills board. We'll try to maximize out, what we can throw into that 100 millimeters square. I'm not going to really talk about what this design does. I'm going to save that for a future project video. Right now, let's just look at the board. So here's the board. It's an Eagle. I've already done the layout on it, the schematic hiding back there. Let's go in and do the processing steps that would be required to submit this. So the first is to do the CAM processor. That pops up a dialog, and we do open job, and then we select Gerber 274X. So that particular job file comes with Eagle. You don't have to download any special design rules. Now it automatically sets up to do some stuff here. So the component side, it sets to do component side tops, pads, and vias. That's your top layer. Then the solder side, bottom pads and vias, that's your bottom layer. There's a silk screen for the top that it's going to put your T-place, your T-names, and your dimension. And then there's a stop mask on the top and a stop mask on the bottom. So, Eagle configures all those things for you. All we have to do is click the Process Job button. And it's done just that quick. Now, this is only going to give us one silk screen. On the JLCPCB website, there's instructions if you want a bottom silk screen as well. I usually don't put any bottom silk screen on. So those are our Gerbers. We also need a drill file. So we'll open a job. We'll select Exelon. And now if we scroll down here, we can see that it has checked holes and drills. Those are the two things that we want to go into the drill file. So we will hit Process Job, and we're done. Let me open up a few Explorer windows. So I've got a couple windows here. This one down here is my sort of Eagle working directory. It has all kinds of stuff in it. We need to select the files that we want for this. 1, 2, 3, 4, 5, 6, 7, 8. Those are the ones that we need. The ones that were generated. Make sure you don't miss any of them. A couple times, I'll do this. I'll have a Windows Explorer window open, and it'll pop up some of the files, but not all. So, make sure to refresh your directory if you don't have all the stuff that ought to be there. So we'll just take those, drag those over here into this working area that I've got. And I think a couple of these could possibly be skipped. I think the DRI and the GPI might be skippable. I'm not certain of that. I just take everything it generated. I go in here, add it to a zip file. And then ignore these pop-ups. These are because I use a network file system, and Windows is a little bit pedantic about it. What I usually do is I'll go in here and I'll rename the zip file ISA-PI dport. That way we'll know which one we're uploading later. So that's our simple design. If you'll notice, I actually cut this off here. It's not quite the width of a full ISA card. Cut it off to make it fit within 100 millimeters. Now here's a slightly more complex board. You might recognize this, looks a little bit like Sergei Kiselev's ISA Compact Flash Lite. That's not surprising because it is actually Sergei's design, and I have added a few tweaks to it. I've added a data buffer, and I've added a header so I can turn the ROM on and off from a switch. I needed a couple more boards, so I was going to make use of this JLPCB offer to get myself some boards made for some of my other retro computers. Now you'll notice compared to the board I just showed you, this one's a little bit wider. And to get a full ISA board that goes all the way back to the holes that you need to drill for the mounting bracket, you're going to go over 100 millimeters. And 100 millimeters on many of these board houses is the threshold between the super cheap board and the slightly more expensive board. Now it's not going to be like cost prohibitive, but it's just because it's bigger, it's not going to be a $2 board anymore. The process for generating the files is going to be the same. So we will go down here, CAM processor. Let's open up the CAM processor. Open job. And then, all the layers are there. The component side, solder side, silk screen, solder masks. Just as before, we hit the process job button. Then we'll go File, Open, Job, and then we'll go into Exelon. Just as before, make sure that the right thing's checked, drills and holes are checked. Process Job. Then we'll go in with Explorer again. Explorer, I've still got the files sitting there from the last board. So here are the files that it generated. As usual, there's 1, 2, 3, 4, 5, 6, 7, 8 of them that Eagle made. Copy those over here. Yes, I know Windows. I'm using a network mount. And then we'll take these and we will create a zip file. Rename this zip file to JL, or we'll rename it to ISACF Lite full size. And there we go. So we've got both of these things zipped up. Okay, so let's get our files uploaded to the JLCPCB website. So I'm going to click the quote button. Add your Gerber files. That's what we want to do. And then let's do the smaller board first. I've got the zip file there. It's uploading. And there's a picture of our board, and it looks much like it did in Eagle. It looks right. It's automatically computed the dimensions, 67 by 100. To get the cheap board, I think you have to say 100 by 100 or less. 10 PC boards. We can select different colors, but if we do that, it's going to add a color fee to our order. So let's just stick with green. That's the cheap one. Similarly, if we want a different finish, like lead-free, that's going to add a surface finish cost, or Enig is going to add a surface finish cost. We're sticking with the cheap one, gold fingers. I'm not going to do that. No panelization, no different designs. Always smart to click the Gerber viewer. Let's see how that looks, and then we'll look at our Gerbers and make sure they look correct. There's our board. Look at the top, bottom, analysis. Sometimes I like to click some things on and off just to see what happens. So like if I turn the drills off, we can see all the holes disappeared. That's good. It lets me know that the holes are there. Turn off the silk screen. Yeah, there's what the board looks like without silk screen. Look at the bottom layer. If you wanted to be just perfect, you'd click each of the buttons and check and make sure the bottom layer looked like it should. One good thing to look at always is your vias. If you set up tented vias, you see there's solder mask here around the pad, no solder mask around the via, just as it should be. Now it has this analysis. I haven't seen this on one of the other board houses, but this is kind of cool. It tells me some stuff about what it's done, the trace widths, the spacing, the drill sizes, the width and height of the board, number of layers. It says unexpected error. It's said that on every one I've uploaded. I'm not sure what it's talking about because nobody's ever emailed me and said, you know, hey, there's an error. So maybe that's a superfluous message. I don't know. These two files were skipped. I think these are like drill information, Gerber information by Eagle. It's going to skip them, so I don't see any harm in including them. I always like to include everything that comes out of the Gerber and Exelon generators. Then it just said, you know, these were the files that we uploaded and what it detected. So top and bottom solder masks, bottom layer, top layer. You know, this is all the stuff we want to be in our board. Top silk screen. There was no bottom silk screen. Drill layer. Yes, the Gerber viewer, everything looks good in there. Let's go over here. And then we could just save this to our cart, $2. Build time 2 days. I'm not going to log in because I don't want to put my account details up on the screen, but, you know, hit the save button. It would be saved to your cart. And then let's go back and take a look at what it looks like to do our second board. We'll add Gerber files. This one's going to be a little bit bigger. There we go. So there's our full board. You know, you see this is our compact flash board. There's compact flash socket. You can see this is 104 millimeters. So crossing that 100 millimeter threshold, that upped this cost. Instead of a $2 board, it's now a $14.49 board. What else could we do? I'm going to submit it in white. That's going to add a color charge, so now we're up to $23.49. And then I'm going to tell it I wanted an Enig. That's added a surface finish of $18, so now we're up to $43. And then I'm also going to do this gold fingers. Because, you know, we have an edge card. It'd be nice to have those gold fingers done. Never done the gold fingers before on a board. So this will be a first time for that. We'll see what we get. And then, you know, again, click the Gerber viewer. Always good to look at the Gerber viewer. You know, our top layer is there. You see all of our drill holes, our vias, our solder mask, our silk screen. All looks like it should. Bottom layer's there. It looks like I expect it to look. You know, zoom in if you want. Zoom out. Let's go back to the top. I always like to take a close look, you know, at any surface mount. Make sure it looks like I expect it to do. You know, yeah, there is solder mask for the surface mount. It's like we want. We'll check the analysis results. We got the same thing about that unexpected error. Again, doesn't seem to be a problem. The same thing about the two files that are skipped, the GPI and the DRI. Don't need those. And the same thing about the 6 various Gerber and drill files that were detected. You know, our top solder mask, bottom layer, top layer, silk screen, and the drill layer. Exactly what we expected. Over here, reasonable stuff. It all looks good. Your next step would be to check out your cart and select shipping. DHL shipping, which is like 2 to 3 days from China. That's fantastic shipping to get something that quick. It's only like 18 bucks, so I was surprised. So anyway, I did go ahead and submit this order, processing, and within a few days I should have my boards back, and we will continue the review. Okay, I've just received my package from JLCPCB. I ordered these on a Sunday, and they have arrived here on a Friday. So it was a few days manufacturing time, and then a few days shipping time from China. Let's open. I've already ripped it open. It's DHL kind of package thing. Inside was a box. Let's see what's in here. I don't know what this is. I don't know. It looks useful. Whatever it is. And then we've got some shrink-wrapped boards. It's kind of nice they put the boards in a box. The box offers a little bit more protection. So there's two boards here. The green ones were the cheaper one we made. The white ones were the more expensive one. Let's open them up and take a look. So here is one of the green ones in hot air solder leveling. And let's open one of the white ones. Get my knife out. Pretty thick shrink wrap on here. There. There we go. Okay, so taking a look at the boards, here's the green board. This was the cheap $2 prototype. The board looks good to me. The traces are as they should be. The holes are drilled true. The solder mask is good. The silk screen is nice and readable. Flipping it over. The back side also looks good. Everything is the way I laid it out. The board dimension looks good. Okay, we're starting by taking a look at the green board. This is the hot air solder leveled board. It's in a green solder mask. Panning over the edge connector. Looks pretty good. The silk screen also looks really nice. It's very much readable. There should be a surface mount. Yeah, there's the surface mount package there that I put on the board. Looking at the green board under high magnification, it's you see the solder mask is really tight on this one, which is good. The silk screen is also very clear. It's a little bit hard to get good focus on my camera here, but yeah. Let's pan over and look at that surface mount package. There's the surface mount package. Again, really well lined up with the solder mask. Nice straight lines on the silk screen. My name should be way over here on this side. Yeah, so here you can read the smbaker.com. www. Let's take a look at the back side of the board. Again, good alignment on the solder mask. You know, the holes are very well aligned. Here's the white board. This one we did in Enig. This one also looks fine to me. It's really hard to see the traces. The white solder mask is much more opaque. The silk screen again is good and readable. It's not quite as clear as the silk screen on the green board. I think it's just a difference in process between the white on green and the black on white. Yeah, flipping it over, there's the back side. The back side looks good. The solder mask is all where it's supposed to be. I did not do a silk screen on the back. Okay, now we're taking a look at the whiteboard under the microscope. This one is the Enig finish. There's a lot more contrast on the solder mask on the white. You can very much see how the solder mask is aligned. To me, the silk screen is a little wavier. You can see some jaggies there in what should be straight lines. I'm not sure exactly why that is. But panning around, it looks good and usable. We'll look under higher magnification in a moment. So there's my website address. You can see kind of how it did the silkscreen print there on that. So here's the very fine pitch connector for the compact flash. You can see little or no solder mask in there. Flip over the board, we'll look at the back side. Also looks good. Let's look at it closer. Okay, here is the whiteboard under the highest magnification I can do on my microscope. See, now here you can see how the alignment of the solder mask is on a typical pad. It's not quite perfect. Let's go find that compact flash connector. So here's a compact flash connector. You can see there's a little bit of white solder mask between each pin on the connector. It's a little bit off, but that is a very fine pitch connector. Let's go look over here where my name is. Should be someplace here by the edge. Yeah, so there is my name. Now you can see those jaggies in the silk screen that I was mentioning earlier. I'm not sure if that's just due to the black on white process. Looking at the other side of the whiteboard, here the solder mask is aligned a little bit closer. We don't have one of those edge. We don't have a compact flash surface mount that we can look at. Let's see if there's no silk screen on this backside to look at either. And you could also kind of see the finish there. So here's the green board. It too soldered up really well. This was the hot air solder leveling finish. No issues building this one out. I'm not really going to talk about the purpose of this green board yet. This is a prototype on a design I'm working on. I'm really not ready to disclose what all it's supposed to do yet. It's one of the nice things about ordering a $2 prototype. You know, I get my prototype and I can try it out and revise if I need to, and it only cost me a couple bucks, and I had it within a week. But yeah, it all worked out fine on this one. Here is the completed whiteboard. This is a compact flash adapter, an ISA compact flash adapter. I've already tried it out. It works. The board looks good. The white silk screen gives you really nice contrast between board and components. Everything mounted up just fine. It's always a kind of a pain to solder these fine pitch surface mount components, but I got it right with my hot air iron with just a little bit of cleanup. Back of the board. Chart, everything worked out on this one. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.